Now let's talk about the new topic, which is friction. Friction is a term which we generally use in our day-to-day life, and we are very much familiar with that. But still, we do not have in-depth knowledge about this particular word. So let's see what do we mean by friction and how we are going to deal with it. So when we throw a ball on the floor, it starts moving with some velocity. But ideally, no force should be acting in the direction of motion, and according to Newton's first law of motion, the ball should keep rolling, but this does not happen. Why? Instead of that, what happened is, after moving to certain distance, a ball stops by its own self. This is happening only due to friction, right? So friction is what? It is a force which acts against motion. A force which acts against any kind of motion is termed as friction. So if you can see in this figure also, this is the direction of motion, we are pushing it, but friction will always act opposite to it. Right? Now, what are different laws of friction? We need to learn all these laws one by one. So there are basically 5 laws of friction. The maximum static frictional force is directly proportional to the normal force, which is termed as limiting friction. Friction act in the direction opposite to direction of motion. Friction force is independent of area of contact, as well as friction force depend on the nature of surface, and kinetic friction is independent of sliding velocity. So let's see them one by one. Coming to first law, that is the maximum static friction force. Maximum static friction force, also known as limiting friction, is directly proportional to normal force. It is directly proportional to normal force. Right? So if you are pushing them this word, this will be the friction force, which is normal to the force. Right? So force due to static is directly proportional to an capital N, that is normal. So the maximum static frictional force is also known as limiting friction. It is also known as limiting friction. This law simply tells us that the normal reaction increases, the frictional force will also increase, and the normal reaction depends on the weight of the object. This law of friction is known as Amon's law, right? It is also known as Amon's first law. So here you can see the figure or a graph for friction plot. As applied force in Newton increases, friction resistance will be increased in terms of Newton, and here applied force is less than friction force, right? So there is no motion, and when applied force is greater than friction force, then the body will suffer motion. Come to the next force, next law, which is law of friction associated, which is friction act in the direction opposite to direction of motion. This law correlates with the definition of friction and states that friction is a resisting force. It always acts opposite to the direction of push or pull. Whether you are pushing it or pulling it, it will always work opposite to it. So as you can see, a girl is pushing this particular block, and kinetic friction is acting opposite to that action. So this is our second law of friction. Coming to the third law, the frictional force is independent of area of contact surface. That means whether the area of contact is smaller or the area of contact is larger, friction force will remain the same. Right? So consider these two Lego blocks or Lego bricks which are kept over the table or over the wooden table. Once in a while, if we see any such activity, we will have a perception that larger block will suffer more friction compared to smaller block. But this is completely wrong. Both of them will have the same friction. As we know that pressure is equal to force per unit area. For object with the same mass, it means that increase in contact area is offset by a corresponding reduction in pressure. So the frictional force will therefore remain unchanged irrespective of area of contact. When this will happen? Only and only when both the block will have same mass. If mass is going to change, friction will correspondingly change. So surface area is irrespective of the block. So here you can see that both the blocks are having different size but mass is same, so friction applied will be same. Then comes frictional force depend on the nature of surface in contact. This is very important and we have experienced this in our day-to-day life as well. The nature of surface which is coming in contact affects the coefficient of friction and ultimately affects the value of friction. Surfaces like higher friction coefficient like rubber or pavement, we know them, while other have low friction coefficient like ice, steel, etc. The rough surfaces will have more friction. More the smoother the surface is, lesser the friction will be. Right? So static friction is directly proportional to force and F is equals to mu into N. Mu is basically coefficient of friction. So we must remember that mu is coefficient of friction, The surface nature varies based on certain forces like specific material property, smoothness or roughness of contact surface, dryness or wetness of surface, and this particular friction law is also known as Emontonus' second law. We have seen Emontonus' first law and this is Emontonus' second law. Coming next is kinetic friction is independent of sliding velocity. Also, this particular point is known as Colombo's law of friction. Right? Kinetic friction is also known as Colombo's law of friction. So what does it say is that kinetic friction exerted between the contact surface of two dry solids is not affected by magnitude of relative surface velocity. So kinetic friction depends on factors like kinetic coefficient of friction and normal forces. Kinetic force is independent of sliding velocity. This particular term is associated or known as Colombo's law of friction. Now here you can see there are various types of friction, we know them. Static friction, sliding friction, rolling friction or fluid friction. Right, there are various categories of friction. Now let's see what are those. First is static friction. When two static surfaces are at rest with each other, the friction that acts between them is a static friction. When a limited amount of force is applied to the body, the amount of static friction is equal to, or the amount of static force is equal to opposite direction. Right? So static friction reaches the saturation point. So here you can see static friction is created between your shoes and the road while you are walking or hiking or anything like that. Heat is produced as a result of static friction which is created by rubbing your hands together. When you rub your hand together, there is a generation of energy. That's why we feel warmth, and that is nothing but due to static friction. A table lamp on the table is also an example of static friction. Then comes a sliding friction. When a body moving or sliding over a surface, the force acting on it is termed as static sliding friction, right? It is termed as sliding friction. It is easier to slide furniture after you start moving it than to move the furniture initially. This is just because static friction is much more stronger than a sliding friction, right? Static friction is much more stronger than a sliding friction. And some examples of sliding friction are use of brake of bikes retard the vehicles or wheel by creating sliding. Friction between bike rims and bike pads, or you can say two cars sliding against each other. All these are examples of sliding friction. Then comes a rolling friction. Rolling friction is basically the weakest types of friction we encounter, and it provides less friction between the surfaces because the weak nature of rolling friction, bicycles, car, roller, etc. can easily rotate. Fluid friction. Fluid friction takes place between fluid layers that are moving opposite to each other. This internal conflict of flow is named as viscosity, right? Fluid friction, we also termed it as a viscosity. Then comes a kinetic friction. This kinetic friction is a friction which acts upon two objects sliding on, moving on each other. It is exerted by some surface to another when two surfaces rub against each other. There is a kinetic friction which is generated. Now let's talk about coefficient of friction. Coefficient of friction is basically measure of amount of friction existing between two bodies or two surfaces, and it is given by frictional force which is applied upon normal force, right? Frictional force upon normal force gives you coefficient of friction. Let's talk about angle of friction. So angle of friction is defined as angle made by resultant force or made by resultant of the normal reaction and the limiting force of friction with the normal reaction. That angle is termed as angle of reaction. S is the resultant normal reaction, R is the normal reaction over here, right? So this is how you can calculate angle of friction. And there is an angle of repose. So what do we mean by angle of repose? It is basically maximum angle of inclined plane on which the body tends to move down the plane due to its own weight, right? It is given by R equals to W cos into A. So consider the equilibrium of a body when body is just at the point of slide. Resolving all the forces, you may find mu, that is R friction coefficient, into R is equals to W into sine A, or you can further reduce it to R equals to W cos